Let's consider the results of a collision. The laws of physics are the same as they are for all sorts of things that we've considered before, but now the forces that are interacting between two objects when they come together interact for such a short period of time that it's hard to keep track of what the acceleration is doing and what the velocity is doing. So what we want to look for is to see if there's some quantity that's conserved when these two guys bang together. Well, it's not the speed, because these guys have different speeds. It's not the total energy, and I'll show you why, and I'll show you an example in just a little bit that it's not the energy. Here's a different kind of collision. In that one, they stuck together. In this one, I have magnets on the two ends so that when they hit, they bounce off like that. And they seem to have more energy than they did in the other case. Here's the case with Velcro on the two sides, and when they come together, they more or less stop. Now, trust me when I tell you that if I had chosen the initial speeds to be just right, I could have gotten them to stop completely. So we know that it's not kinetic energy that is the quantity that's conserved here, that's the same before and after. What is the same before and after is a quantity known as momentum. We use the letter P to stand for momentum, and the momentum is equal to the mass times the velocity. The velocity is a vector quantity, and so I write momentum as a vector as well. In one dimension, I can write it like this without the vector symbols, just remembering that if the momentum is to the right, it's a positive quantity. If it's to the left, it's a negative quantity. And when I plug in P equals mv for all these quantities, here's the equation I get. Now, if I know the initial conditions, which are the two masses and the initial velocities, then this is one equation in two unknowns, because I don't know V final for either mass 1 or mass 2. All right, this tells me that I need to know more information. In the cases that I showed you before, it makes a difference whether or not these two guys stick together or are repelled. So I'm going to need that equation up there on the board plus one more equation in order to figure out the final velocities.